to a new section today, 2.4 variables, equations, and solving equations using addition and subtraction. Not only is the title long, but there's a lot of material in this section. We'll go through it quickly, but at the same time, if I go too fast, you can always come back to this. It's a YouTube video. You can come back, go forward, rewind, so to say, to make sure that you get a good understanding of this, because this is extremely important. Equations are critical. If you can't solve an equation in algebra, then you don't go on, you don't pass algebra. All right, first things first. Definition. A basic definition of an equation is a mathematical sentence formed by placing an equal sign between two expressions, as you can see here with the example. Here's an expression, I have an equal sign in between. That's considered an equation. There are numerical equations like 5 plus 2 equals 7, but this one has the variable. We're looking at variable equations here, and then we're also looking to be able to solve these kinds of equations. So let's define what a solution is. A solution of an equation is a number that produces a true statement when it is substituted for the variable, which means I need to find a number that if I put it here and put it here and do the arithmetic on both sides, I get a true statement. As it turns out, it's kind of tough to just look at it and know what the answer would be. It turns out it's 10. 10 plus 7 is 17. 2 times 10, 20, minus 3 is 17. That's hard to use mental math and just look at that and be able to come up with the answer quickly. So we're going to show you a series of properties and a series of steps to be able to solve equations that look like this. Not all in the first section, but throughout the remainder of the sections in this chapter and into next chapter also. So what we're going to do now is we're going to first, before we start solving, we're going to rewrite English expressions into algebraic expressions that give us equations. We're going to write the verbal sentence as an equation. Now the key word here is. Because when you see the word is, they're talking equality. Same thing as if they say something like is the same as. That's equality. Now we know that sum, S-U-M, refers to addition. So we're taking the sum of x and 9, that would be x plus 9, and this is equals 17. There's my equation. And using a little mental math, I know that the solution to that equation, the answer to that equation, the root of that equation is 8. That's what makes this true. If I substitute the x in with an 8. Now over here it says the quotient of 20 and x. Now we remember quotient means division. So the quotient of 20 and x, the first thing that's listed is the numerator. The second thing that's listed is the denominator, or the divisor. The quotient of 20 and x is 20 over x, and this is negative 5 equals negative 5. Now this one, again, we could look at this and we could plug some numbers in, and we could see that using a little mental math that the solution to that equation would be negative 4. 20 divided by negative 4 is negative 5. Now here's some equations below where we're going to use mental math to solve. So we just have to kind of look at this as a puzzle. What would we substitute in to make it true? Now in this case, negative 36 is equal to 4 times d, 4d. 4 times, this is the riddle, 4 times what number is negative 36? Well, that would be negative 9. So we write d equals negative 9. We write it, not just negative 9 and circle that, we write d equals negative 9 because that's our unknown in this equation, and we want to stay with the unknown as equal to, that would make it true. Now the next one, my unknown is h. I have 54 minus h is 48. So the riddle here is saying 54 minus what number is 48? Well, again, we can think about this. This isn't going to be too difficult. H would have to be a 6 because 54 minus 6 is equal to 48. So h is equal to 6. Again, I write h equals 6. I don't just write down 6. I write h equals 6. The next one up, what number x over negative 3 equals 12? The riddle is what number divided by negative 3 is equal to a positive 12? Well, we know a negative divided by a negative is positive, and of course 36 divided by 3 is 12. So in this case, our solution would be negative 36. Negative 36 divided by negative 3 is positive 12. And the last one here, this is a little bit easier because we have all positives. 4 is equal to 36 over x, so this is saying 36 divided by what number is equal to 4? Well, 36 divided by 9 is 4, so we'll write x equals 9. Now, if you say, well, the variable was on the right side of the equation, should we have written 9 equals x? Well, they represent the same thing. Well, traditionally, we put the variable on the left side, but it doesn't have to be because of a very important property in algebra called the symmetric property of equality, which says that if you switch the sides of an equation around, you still have equality. If A equals B, then B equals A. If X equals 9, then 9 equals X. The equations that we just looked at were all simple enough that we could figure out the answers in our head, use a little mental math. And they're going to get more difficult. Like the very first example was a little bit tricky to figure out that the answer was 10. So what we're going to do is we're going to learn a method to be able to determine the solution to an equation without having to sit there and just substitute numbers in until we get the right combination. And we're going to use the idea of inverse operations. Now, we're going to start off, this is the contradiction, we're going to start off with some equations that are probably easy enough that you can use mental math to solve. But we have to start with the easy ones and work our way to the more difficult ones in some of the later sections because we need to learn the steps from the beginning. So the steps are going to involve a couple of properties, which I have written out, and these properties use, again, the idea of inverse operations. Inverse operations are kind of a terrible definition. They undo each other. Adding undoes does subtraction. Subtraction undoes addition. Multiplying undoes division. Division undoes multiplication. We're going to start off with addition and subtraction. If you think of your favorite number, you add 10 to it, get that, then subtract 10, you get right back to where you started because the plus 10 and the minus 10 cancel one another out. They undo one another. So the first property we're going to look at is called the subtraction property of equality. Very important. It says if A, B, and C are real numbers and if A equals B, so this part is given, that this is equal to this. We don't know what the numbers are, but we have equality. Then A minus C equals B minus C, which is saying that if you have equality and you subtract the same amount from each side, you still have equality. Okay? If you have equality, A equals B, and you subtract C from both sides, A minus C is going to equal B minus C because you took equal amounts off of each side, and the sides were equal to begin with. So what I have here are three examples where I'm going to use this property. It says solve and check. I'll show you what the check is. Now, to solve the equation, I'm going to show you two methods. I really don't care which method you use to solve. I'm pretty sure I know which one you probably use. But the other method, even though it might take a little bit more writing, is a little bit more algebraically correct. So a little bit more formal. So our first equation here is x plus 5 equals negative 2. And those of you that are really good with mental math, you already have the answer. But what we want to do is we want to find out what number we're going to add to 5 to get negative 2. We want to get x. We want to find out what number x represents. And so what we're going to do is we're going to isolate x on one side of the equation. In this case, it's already on the left side. We're going to isolate it on the left side. To do that, I've got to get rid of this plus 5. Now here's where the inverse operations. What's the inverse of adding? Well, that'd be subtracting. Now this property says I can subtract the same amount from both sides. I want to get rid of this plus 5. I'm thinking I'm going to subtract 5. If you add 5 then subtract 5, they cancel one another out. They undo one another. So what I'm going to do is I'm going to write the side down again, x plus 5, and then I'm going to subtract 5 from it. And on the other side, remember the equality, if you do it to one side, you have to do it to the other side. I'm going to subtract 5 from the other side. See how I put it on the ends like that? I'm minus 5 and a minus 5 on the ends of both sides of this equation. Now here, the plus 5 and the minus 5 do exactly what I want them to do, and that's to undo one another or to cancel one another out. So these are going to cancel out, and I'm going to get x. Now you don't have to put the slashes through by any means. I'm doing that just to kind of represent that they're undoing one another, canceling one another out. On the right side, I have a little arithmetic problem, negative 2 minus 5. Now, of course, when you subtract, a non-traditional subtraction problem, that's the same as adding the opposite. That's the same as negative 2 plus negative 5, which is negative 7. Again, those of you that are good with mental math, you already had this answer minutes ago. So what we're going to do now is we're going to circle this as our answer, that if x equals negative 7. Now, the definition of a solution was that if you substitute it in for the variable, it makes it true. So that's how you check your answer. You use the definition. I'm going to write a little CK here for check. And I'm going to take the negative 7 and I'm going to substitute it in for the x in this original problem right here. So that's negative 7 plus 5 equals negative 2. Well, negative 7 plus 5, one of each, subtract, take the sign of the bigger. I get negative 2 on this side, I get negative 2 on that side. That's a true statement. that's a good answer. This is not my answer. This verifies that this is my answer right here. That's why I circled it. Now, some of you students are not used to writing this step out this way. You're going to be used to writing it out a little bit different. That's what I'm going to show you in example B here. G plus 3 equals -8. Now, it's very much like the last example. My variable's on the left side of the equation, and there's a number being added to it, G plus 3. So just like I wanted to get rid of the plus 5 here by subtracting 5, I'm going to get rid of the plus 3 here by subtracting 3. But instead of writing it out this way, I'm going to show you a little shortcut. Now, I'm not crazy about shortcuts because sometimes students kind of lose track of what the shortcut actually means. But it's the reason that I can do this. It's this property. I'm going to subtract a 3 from both sides, and I'm going to put it like I was doing a little arithmetic problem, even with a total bar. So that on the left side of the equal sign, I have the plus 3 here and the minus 3 here, and they cancel out. So that just leaves the G. And on the right side, I have -8 and -3. Remember, subtracting 3 is the same as adding -3. That's a -11. And that's my solution. At least I hope that it's my solution. Let me check. I'll take the -11 and I'll plug it back into the original problem in for the variable. -11 plus 3 equals -8. -11 plus 3, one of each, subtract, take the sign of the bigger looking one. I get -8 equals -8. It checks out just fine. Now, the check is a good thing to do, especially when the equations become more complicated. But if you practice working the checks out on these simpler equations, these are called one-step equations, by the time we get to the more difficult equations, you'll be ready for those. You'll know what to do. All right, the next example, the variable's on the right side, but don't panic here. I'm going to work it the same way. Okay, I'm going to isolate the variable by getting rid of the plus 3. The 3 is being added to m. So just like I had a plus 3 here and I subtracted 3, I'm going to subtract 3 from both sides here. -3 here, -3 here. A -62 and a -3, a negative and a negative, that is a -65. And of course, these are going to cancel, and I get my answer this way. Now, if you're thinking, oh, I have to have the variable on the left side, you said it was more traditional to put it on the left side, but I also said it didn't matter. You can leave your answer that way, no problem. That'll be fine. All right, so my answer is -65. M equals -65. So let's check. -65 right in here for the m, right there. So I get -62 equals -65 plus 3. Well, on the right side, the left side's already done, simplified, but on the right side, I'm adding a negative and a positive. So again, I treat them like they're positive, subtract, take the sign of the bigger, and you got it. It checks out okay. Now, if your check doesn't give you the same number on both sides, that probably means you made a mistake either with the check, or more likely, you have the wrong answer. Go back and try the problem again. I've seen students get the wrong answer, substitute it in, get the check wrong, and then just change the check at the bottom and write -62 equals -62, even though that's not what they got. So you have to make sure that you use the check for what it's there for, to see if your answer is correct. And if your answer is not right, you make the adjustment. You go back and redo the problem. Just changing the check around is kind of like taking a jigsaw puzzle and scissors and cutting the pieces so that they fit, whether they're supposed to fit there or not. All right, the second property, very key, the addition property of equality. If A, B, and C are real numbers, and if A equals B, then A plus C equals B plus C. Now, this is just the opposite. This says that if we have equality, you can add the same number to both sides. I tell students sometimes, think of a balance or scales. If you have equilibrium, if you have the two sides perfectly balanced, and then you add the same amount of weights to both sides of the scales, it stays balanced. You keep that equilibrium, you keep equality. So I'm going to use that idea to work these examples out here. I'm solving 3 equations. Notice that your variable is in each equation. Here it's the y, here it's the variable p, here it's the variable h. So in this first one, it's y minus 4 equals -11. I want to find out what y is. And again, those of you mental mathers probably already have the answer. But I'm going to show you the work to get the answer, whether you can figure it out that way or not. And this is the way I'd like for you to work. So I'm going to do it the more traditional way. To undo the -4, to get the y all by itself. Remember, to undo means use inverse operation, and the inverse of subtraction is addition. That's where this property comes in. So to get rid of a -4, I'm going to add 4. I'm going to write the side down, and then I'm going to add 4 to it. And then just like I have here, I'm going to write the side down, and then I'm going to add 4 to it. That's why this is a better way to show your work, because it follows this property more precisely than the little shortcut did on those examples there. But again, I'll accept that. So in this case, the minus 4 and the plus 4 do exactly what we want. They cancel out. I get y equals a negative 11, and a positive 4 is a negative 7. One of each, subtract, take the sign of the bigger. That's my answer. Now, I really didn't leave myself very much room to show a check there, but you would take the negative 7 and substitute it in to C. In the next problem here, the variable's on the right side. Again, that doesn't matter. If you can't stand that variable being on the right side, you can use the symmetric property of equality, flip the sides around, write p minus 62 equals 26, and solve it that way. But I'm going to leave it as is. I'm going to get the minus 62 away from the variable p. I'm trying to isolate that variable there. To undo a minus 62, I'm going to add 62, and I'm going to add 62 to both sides. I'm going to add 62 to this side. I'm going to add 62 to this side. Now on the left side, 26 and 62 is 78. On the right side, the minus 62 and the plus 62 do exactly what we hope. They cancel out, and I get my answer as 78 equals p, or p equals 78. And I worked at showing the steps just like the first example there. This last example, I'm going to use the shortcut. I have h minus 1 equals negative 16. The minus 1 is the problem because I need to get the h all by itself. So I'm going to get rid of the minus 1 by doing the inverse operation of subtracting 1. I'm going to add 1. So I'm going to put a little plus 1. And of course, if I do it to the left, do it to the right. On the left side, the minus 1, the plus 1, they're going to cancel out. The variable h is all by itself. And on the right side, I have a negative 16 and a positive 1. One of each, subtract, take the sign of the bigger, I get a negative 15. And that's my answer. Now, you have to get good at solving equations. We start out with the simple ones, and we work our way to progressively more difficult problems. These are called one-step equations because there's one transformation. We're adding something to both sides, we're subtracting something from both sides, and we get our solution. But eventually, we're going to get to equations that are going to require more steps than this, and they're going to become a little bit more difficult, a little bit trickier if you're not practicing the easier ones now. So remember, practice, practice, practice.